everyone. In this lesson, we're going to be talking about something called nets. If we were in class, we'd be doing a really awesome hands-on activity. And you're welcome to try this at home, especially if you have some sort of grid paper to do this with. So first, let's make sure we're clear on the definition of a cube. A cube is a three-dimensional shape with 6 identical faces. Faces being, I don't know, if you think about a die, like when you roll dice, each of the numbers is on a different face. Okay, so a unit cube is a specific cube where each of the edges are just 1 unit long. So 1 high, 1 wide, 1 long, 1 deep, whatever you want to call it. A net is a 2-dimensional pattern that can be folded to form a 3-dimensional figure. So we're going to talk specifically about how to make a 2-dimensional pattern that could be folded into a unit cube. So imagine that we could cut out these cubes, and maybe you could try this at home if you're so inclined. We want to be able to cut them out so that we could fold them together and it would form a cube. So I'm going to show you the first one. I'm going to shade in the squares that I'd want to cut out. So let me just get it inside the lines there. That's right. That's good enough. All right. If I cut out those squares right there, it might be hard to talk about visually here, but these 2 edges here would fold up together and meet, just like these 2 edges here would fold up and meet. And these 2 edges here would fold up and meet, just like these 2 edges here would fold up and meet. This square here would end up being directly above this square here, and we would make a cube. I'll go ahead and show you at least one other version of a net for a cube. We could do the following pattern. We could have square up there, long line there, and a square down there. This would actually be the net of a cube. So you have to kind of imagine this middle piece kind of wrapping around. So you've got kind of a big chain there with 4 sides, and then this could be like the left and right sides. They'd be facing opposite of each other. So that's 2 different nets for how to make a unit cube. There's actually a total of 11. So if you're interested in trying that, you can try to go ahead and find all of the other different nets that would make a unit cube. Now, if you're trying this, be aware that when I mean 11, I mean not ones that would be the same if you flipped or turned them. So, for instance, that one is actually the same as your first one because it's really just upside down of the first one. So that does not count as an additional one. These 2 count as different because there's no way I could flip, turn, or rotate them so that the one lands on top of the other. So no to this one, but there's actually 9 more ways. So I've given you 2. There's a total of 11. Okay. You can also do the activity with rectangular prisms, but there's a ton more of that. Okay, so what I want to talk about is being able to match nets to the 3-dimensional shape that they go along with. So this shape here is a triangular prism. So we see a triangle here, and there would be a triangle on the back side here. So we can kind of draw the transparent version here. So if we kind of look at this shape, we see that there are 2 triangles. And so if we unfolded it, those 2 triangles would lay flat. But what are the other shapes that it's composed of? So up top here we have a rectangle. On the bottom we have a rectangle, and on that side that we really can't see, we have another rectangle. So this shape is really 2 triangles and 3 rectangles. So if we look at the options here, this has got to be option 2. And as I said, it is a triangular prism. A prism is any time we've got basically 2 shapes that are almost kind of like stretched apart from each other. So here's a triangle and here's a triangle. those are the two bases of this figure, and they're just basically connected with a solid in between them. So a triangular prism has two triangles on opposite sides. If it was two hexagons instead of two triangles, that would be a hexagonal prism. So that's all of the prisms are like that. Triangular prism and rectangular prism are really the only ones we're going to be focusing on. All right, so if we look at this shape, this is actually not a PSSA shape, but we can handle it. We've got a triangle, and we've got two triangles in the back that we can't exactly see. And then we've got a square on the bottom. So we kind of look at all those faces and imagine it unfolding. So if we look at our options here, we see this one up top has four triangles and a square at the bottom. This is actually a square pyramid. Why a square pyramid? Well, the base is a square, and a pyramid is any time the shape comes to a point. So it comes to a point, pyramid, the base shape is a square, so it's a square pyramid. If we had a triangle on the bottom and they came to a point, it would be a triangular pyramid. Okay, this next shape is a whole bunch of rectangles. Some of them are different sizes, and the top might even look kind of like a square, but a square is still a rectangle. So we've really just got a whole bunch of rectangles. And that one must clearly go with this shape down here. So this is a rectangular prism. Rectangular prism. So to kind of follow along with the definition we have at the top, we could see like a rectangle here, if we wanted to pick that one, and a rectangle over there. They're kind of stretched apart from each other. Those could be the two bases for a rectangular prism. Lastly, we have this shape, which is a whole bunch of squares connected. Every face is a square, so this is a cube. Great. And so on the left side we have nets. On the right side we have the three-dimensional shapes that go along with them. So some of these are not required to know the names of them, but go ahead and do your best to see if you can do the same for this shape to determine some of the nets and how they match to the three-dimensional solids. And then, again, try here as well to see if you can match all the nets with their three-dimensional shapes.